Welcome back, and thank you very much for watching this lecture video. Last lecture, I went through nomenclature of aromatic compound, and we said what will happen if we have one or two substituent. Now, the question is, what will happen if we have three or more substituent? In that case, the first question I'm going to ask, do I have any functional group? If the answer is yes, then treat it as the main parent, and anything else, it will be the substituent. And so, for example, in this case, I'm going to say I have a functional group is OH, and this one is attached to the ring. So this one, it will be a phenol. So I'm going to say I have a phenol and with a bunch of substituent. And the first one, I have methyl attached to the ring. This is going to be toluene. So you can treat it as a toluene molecule with two substituent, chloro and nitrate. And last one, I don't have a specific functional group, and so just simply treat them as three different functional substituent, and try to get the smallest possible number. We can do the same thing with the first one. So the first one, I can just simply say I don't have any specific functional group or any common name. If I don't have any common name, I can just simply label them and try to get the smallest possible number. So I have 1, 2, and 4, and I go 4 chloro, and then 2 nitro. Oh, forgive me. 1 methyl, and then 2 nitro. And at the end, we're going to say benzene. Okay, that's one way to name it. Another way to name it, treat this one as base molecule. The base molecule, this is going to be toluene, and the second and fourth one, you have nitro and chloro. So I go on the fourth one, I have chloro. Next, on the second one, I have nitro. The name of the molecule, it will be toluene. So 4 chloro, 2 nitro, toluene. Next one, the functional group is OH. So how about treating it as a phenol? And I can say I have a phenol molecule with 3 bromo substituent. So I go 2, 4, and 6 tri bromo phenol, and that's going to be the correct name for it. Okay, last one. And last one, we don't have any specific functional group or common name. So simply let's give them the smallest possible numbers. And I'm going to start with the ethyl. Why? Because I get 1, 2, and 4. And if I start with nitro, I get 1, 3, and 4. So right now we have 1, 2, and 4. If I start from nitro, I get 1, 3, and 4. If I start from bromo, I get 1, 2, and then 4. Let's see, 1, 2, 3, 4, 5. So I get 5, not 4. If I start from bromo. So the correct way to label it is to start from ethyl group. Okay, so ethyl, it will be the right one. And we have ethyl, bromo, and nitro. Bromo will get a priority, so I go 2 bromo. Next, we have ethyl. So we go 1 ethyl. And last one is 4 nitro. And name of the ring is benzene. So we're going to end the name with benzene. 2 bromo, 1 ethyl, 4 nitro, benzene. Okay. Now, I have a good number of an example here, and I want you to give it a try. Pause the video here and try to get the name by yourself. Okay, so assume you give it a try, and so I'm going to highlight the main chain. Okay, this time I decided to label the highlight the methyl with the ring as well, and this is going to be toluene. I have a toluene and iodide attached to it. So one way to name it is to say 1, 2, 3 on the third carbon we have iodo, and then say toluene. or you can say 1 iodo, and then 3 methyl, and then end the name with benzene. Okay. So we have two methods two ways to name that compound. Okay. Now I'm gonna try to highlight all functional group and the main technically the common name that you should use. Okay. Here we have a carboxylic group. It is attached. Forgive me. Carboxylic group attached to the ring. So this one, the name for the parent, it will be benzoic acid. And you do have two substituents on it, so try to figure name for it. And next one, I don't have any functional group, so simply I will label them. For the first one, I said here 1, 2, 3, 4, 5, and 6. So on 3 and 5 you have bromos, and here we don't have any specific thing, so I go 1, 2, 3, and 4. Okay, now how about next one? Next one, we do have a double bond, and because we have a double bond, you have to start the labeling from here. 1, 2, 3. Okay, and you treat the phenyl as one substituent that's sitting on the third carbon. Okay, now we have alcohol, OH, is sitting on benzylic carbon, which one is gonna be the main parent, the one that has the alcohol, and that one. That it has a 3 carbons, so that's a propane with 2 substituent, OH and phenyl ring. And how about next one? Next one, we have a double bond. This is going to be the main chain. And so it will be 1, 2, 3, 4, 5. This is the pentene. Okay, pentene with 2 substituent, and 2 of them are phenyl. And here we have a benzylic carboxylic group that attached to the ring. So this one, it will be benzoic acid. The base, it will be benzoic acid. You have methyl, you can say 3 methyl benzoic acid, or you can say methyl benzoic acid. Okay, that's another way to name it. So 3-methyl benzoic acid or methyl methyl benzoic acid. Okay, next one we have a methoxy attached to the ring. So this one, it will be anisole, and you have chloro and ethyl there. So you can say this is going to be 1, 2, 3. Forgive me. 1, 2, 3, 4. Okay, so on 3 and 4, you have chloro, ethyl, and chloro. Chloro, it will get a priority over ethyl. Next one, we have aldehyde attached to the ring. So this one, it will be benzaldehyde. The base will be benzaldehyde. Okay, and you do have chloro-bromo there. So you say this is going to be 1, 2, 3. Why I turn to bromo? Because bromo will get a priority over chloro. So this one, it will be, okay, 3 bromo. Next, I go 5 chloro. 5 chloro benzaldehyde. So 3 methyl, 5 chloro benzaldehyde. Okay, and again, try to go through the names by yourself, and I try to highlight the main chain or the parent technically, or the base of the molecule, but I did not mention the full name of each molecule, and try to do it by yourself. Okay. I'm going to practice these 2 examples, and I will end the lecture. Here we have a double bond, and because we have a double bond, the main chain or the parent chain, it must include the double bond. So I'm going to highlight this. This one, it has 5 carbon. Where's the double bond? Is sitting on the 3rd carbon. Doesn't matter from which side you start. 1, 2, 3, 4, 5, 6. So is instead of pentane, it will be pentene. And now on the 3rd and 4th one, I have 2 phenyl groups. So I go 3 and 4 diphenyl And then I say pentene. Okay, pentene. 3 and 4 diphenyl pentene. Another one. Okay, this is going to be the main chain. You start labeling from here. You get double bond, the lowest possible number. So you say 1, 2, 3. On the third one, we have a phenyl group. So this one, it will be 3 phenyl. And the main change, it has 3 carbon. So it will be propene. 3 phenyl, propene. And phenyl, when you say 3 phenyl, okay, I forgot the L here. 3 phenyl, you already showed how far, you already showed position of the double bonds. Phenyl is a 3 carbons far from the double bond. So no need to say where the double bond is, because you already mentioned it by saying position of the phenyl relative to the double bond. And this is going to be end of this lecture. And thank you very much.